Bismillahirrahmanirrahim. So today we'll be trying to discuss an important question, an important topic in your organic chemistry. Now this is very important topic as far as your M.Sc is concerned. यानी ये जो usually topic है ये आपके M.Sc के syllabus में होता है in the organic chemistry. But in addition to that, जो गेट के का पेपर होता है आपका जो M.Sc के बाद जो भी कॉम्पिटिटिव एग्जाम्स होते हैं, whether it is JRF, NET or any exam through which you can get admission in any Indian Institute of Science or Indian Institute of Technology and so on. तो ये बहुत important topic है. The topic I have decided is basically I decided this due to the reason that some of the students requested to make this simple and to understand the basics of this topic. The topic basically क्या है? There's a topic called as the Hammett Equation. So there's a topic called as Hammett Equation. So topic basically है that is your Hammett equation. So if there's a mistake in the spelling, so please correct that. So this is the topic, Hammett equation. अब ये जो topic है, I will not be discussing this in the great detail. Rather, I will discuss the basics out of it so that the student gets the main cream, main cracks, and rest he will be in a position, he or she should be in a position to read it easily from any textbook. The Hammett equation जो है इसको मैं understand करने के लिए I will take 2 classes. I will take very short classes, maybe 20 to 30 minutes, but 2 classes. So one is today and there will be one more class. So please understand both these, follow both these classes, and then if you still have any question then we'll discuss that. So basically ये Hammett equation होता क्या? So what this Hammett equation is basically. So let me write down first the equation in general. तो Hammett equation हम लिखते हैं, we write it like this: logarithm of kx by kh is equivalent to sigma x multiplied by rho x. So this is your Hammett equation in general. अब मैं इसको दोबारा पढ़ लेता हूं. Logarithm of kx, this is kh, this is sigma x and this is rho x. Now Hammett equation को understand करने के लिए each and every term we have to understand. But at the moment we'll just keep in mind one thing here so that we will come to the conclusion what this all about is. We have kx. Now that kx basically, what is this kx? देखिए we know that जितनी भी chemical reactions होती है, there is ultimately one thing, that the reactants, let us say the reactant A and B, they will react together and they will form a product B. ठीक? And this reaction can be reversible or this can be irreversible. So if it is irreversible, then I will show it with this arrow. If it is irreversible, then I will show it like this. ठीक है? So if I write like this is the reaction which is irreversible, then I will write K here. So that K basically means reaction constant. It tells you about the rate of the reaction, K. So I will write down K is the rate of reaction. Or if I write down K here, it means equilibrium constant. So please try to understand this. So any reaction we have, any chemical reaction, the reactants will react together to form the product. So if it is a reversible, then we have the equilibrium constant, that's K. If it is a reversible reaction, then that becomes a reaction constant. That tells you the rate of the reaction. यानी किस rate से A and B combine and they form the product P. Now there are different types of chemical reactions in the organic chemistry. For example, we have let's say nucleophilic addition. मैं just few reactions को यहाँ पे लिख लेता हूँ. Nucleophilic addition, so that we will try to understand what this Hammett equation is. There are the reactions like ester hydrolysis. Then we have substitution reactions, and then we have, for example, if it's a carboxylic acid, we have dissociation reactions. And acid, you dissolve that, it gives ions. If it's carboxylic acid, it gives H plus, and also it gives the negatively charged conjugate base. So let's say it's a dissociation reaction. So it's a reaction called as a dissociation reaction. So there are many chemical reactions. The ultimate reaction में क्या होता है, that we have a reactant side and we have a product side. Now, so if we talk about the rate with which these two reactants react to form the product, or if we want to say that A gets converted to A, B gets converted to A plus and H and B negative. So this is also a chemical reaction, whether it is reversible or whether it is irreversible. Again, I can say the rate of this reaction, that is decomposition of AB or conversion of AB into A plus and B negative. And मैं ये भी कह सकता हूँ that equilibrium constant between this and this. So all this stuff, whether it is dissociation, whether it is an addition reaction, it's a nucleophilic substitution, ester hydrolysis, we are interested in the rate of reaction. किस रेट से एक पर्टिकुलर रिएक्शन ऑकर होती है, whether it is slow, whether it is fast. ठीक, we are always interested in this, number one. So normally क्या होता है, we are interested in the rate of a reaction, a rate of a chemical reaction, whatever type of reaction it is, chemical reaction. Second, अब एक chemical reaction ऑकर होती है, we are always interested in knowing the mechanism of the reaction. ये A and B आपस में अगर react करते हैं तो कैसे करते हैं? Now what is that particular mechanism? And if A, B dissociates, what is that particular mechanism? So we are interested in mechanism of the reaction. So organic chemistry always, you are interested that you should know the mechanism. This is one of the important things in the organic chemistry. Particularly when you do the research, you are interested in knowing the mechanism of the reaction. I want to design a new compound. I want to synthesize a new compound. For that, I have the reactants, but I don't know the mechanism of the reaction. So that's a big process. So I am interested in the mechanism of the reaction. I want to know the rate of the reaction. Rate of the reaction means the reactants react slowly or the reactants react fast. किस rate से वो react करते हैं? ये कुछ basics है in the chemical reactions. Let's keep it aside. Now, ये जो मैंने यहाँ पे लिखा है log of h kx by kh is equal to sigma x multiplied by rho x. ये basically क्या है? देखिए, this is आज की जो class है, we'll only try to understand this and then we'll go deep into its further basics. Let's take the example to understand this, to simplify this. We'll take example of dissociation. We'll take example of an acid called as carboxylic acid. This is an acid called as benzoic acid. And this was the example which was taken by the Hammett, remember this, at the beginning. So we'll take the same example, we'll take the carboxylic acid. We know that this acid it's a fairly weak acid. ठीक, और weak acid पे rate of reaction आप easily understand कर सकते हैं. It's very easy to study the effect of various things to understand the rate of the reaction. So if this carboxylic acid dissociates, it will dissociate into carboxylate ion, and it will also give a proton, because as per the Arrhenius concept, Bronsted concept, any species you dissolve that, it gives a proton, that is a Bronsted acid. ठीक है. और ये जो आपका बन गया नेगेटिव चार्ज, इट्स कॉल्ड conjugate base. Conjugate base. Acids have a conjugate base. So this is your acid, benzoic acid. So it dissociates to you H plus and the conjugate base. ये एक नॉर्मल कॉन्सेप्ट है the acid base chemistry का. Now यहाँ पे एक आइडिया आपको आया होगा, this H actually means what? Now the question is that this H actually means what? It actually means that if you have this benzoic acid, it dissociates to give carboxylate ion and H plus. So this is the rate constant or equilibrium constant. Now we'll write it KH. That means at this position, which is a para position, this is ortho, this is your ortho position, this is your meta position, this is your para position. Same is the case, ortho position, this is your meta position, and this is your para position. So if you have only benzoic acid at these positions, you don't have any substituent. Substituent, electron donating, electron withdrawing, any substituent. So if you don't have any substituent at the moment, then we write KH is basically the dissociation constant, or it's the rate constant for this reaction. So this is your KH. Now what is KX? Now if we put substituent at these positions, meta position or at this para position. Now a question, you can ask the question, now why you are talking about putting the substituent at the meta position, or you are saying putting the substituent at the para position, why not at ortho position? There's a reason. एक concept होता है, I will just discuss it here in the chemistry, that is ortho effect. ये भी acid base chemistry में ही होता है ortho effect. Now as per this effect, I will take the same benzoic acid example. Now we'll write it like C double bond O OH. Okay. Let's say at the ortho, this is benzoic acid. At the ortho position, I should say any substituent X. Now देखा ये गया है after a lot of experiments and a lot of research, that ortho effect always has some interaction with this group, because they are in the close proximity. They always have the interaction, whether it's hydrogen bonding, whether it's steric interaction, whether it's a weak interaction, whatever. They have the interaction. And result is that it has been seen that the acidity of carboxylic acid always increases because of the ortho effect. For example, अगर आप ये कहते हैं कि I want to understand what is the effect of this group at the para position. Irrespective of you put any type of group at the para position, you see that carboxylic acid has its acidity increases irrespective of the group. Why? Because you have a group present at the ortho position. That ortho group, it has an influence on the dissociation constant of this carboxylic acid. And I should in a nutshell say the acidity of the carboxylic acid increases because of the groups at the ortho position. That's called ortho effect in general. Since ortho effect is always there, so that's why the Hammett, he didn't took the concept of the substituent at the ortho position. So now I will not discuss this ortho position. Fine. So when you say the Hammett equation, you will always see meta substituent and the para substituent. Means अगर मैं meta पे या para पे कोई ऐसा group इस ring में insert करूँगा, what is the effect of that group on the acidity? What is the effect of that group on this dissociation? Now that basically, for example, let's take a nitro group here. If I put a nitro substituent here, so if I put a nitro substituent, I will write down So this becomes COOH. So now I have a group at the para position. So this becomes COO negative plus. अब मैं इसकी बात करूंगा, I will not write KH, I will write K substituent at the para. Instead of that, I will write KX. So it means now the rate of the reaction or the equilibrium constant when I have this substituted benzoic acid. Irrespective it is at para, it's at meta. Okay? If it's at para, then obviously I have to think of the para. If it is meta, then I have to think of the meta. But in general, that Kx basically tells me the rate of the reaction, or it tells me for benzoic acid, the dissociation of benzoic acid or the equilibrium constant of the substituted compound. Okay? So this is your Kx and this is your Kh. I hope this is clear. In the Hammett equation, Kx, now it's not necessarily, just meaning yahan bhi kaha ki you will always have the dissociation reaction. It can be a ester hydrolysis. Ester hydrolysis may be, if you want to hydrolyze an ester, now what is the effect of substituent? Then that you will take as Kx, and then if there is no substituent, then ester hydrolysis reaction may, then we'll take as that Kh. Then accordingly we'll see the equation. Okay? So in this case, to understand the basics, it's always, let's take the same example which was taken by the Hammett once he proposed this equation, once he came out with this equation, that is he took the benzoic acid. Number one reason, because it's a weak acid. जब acid weak होता है, उसकी acidity को modify करने के लिए, उस पे effect of substituent को understand करने के लिए it's easy. अगर acid already आपका strong हो, it's very difficult. Since the acid is already strong, how you will say that what is the effect of substituent? So it was an ideal position for him that you take the benzoic acid. उसके बाद, these are two terms. Now then we have this sigma x. Sigma x basically tells you, ये बहुत important है. Now this sigma x, it basically tells you about, or you should say that sigma, it's a measure of आप लिख सकते हो, it's a measure of electronic effects. It's a measure of electronic effects. We'll see that after some time. Then we have one more term. Sorry, this is your sigma. Then we have rho. We have rho x, another term. Rho basically tells you, it helps you to understand the mechanism of the reaction. It's a measure of, it helps you to understand the mechanism of reaction. Okay, or you can say it helps you to understand the transition state. जो भी chemical reaction होती है, there's a transition state. एक intermediate state होता है जहाँ पे old bonds जो है, they are slightly broken and the new bonds have started forming. Now that's a transition state. Okay? So this rho x, it gives you area, it gives you measure of the what you call as the mechanism of the reaction, or it gives you idea about the transition state. And sigma x, it tells you about the electronic effects. Electronic effects क्या होता है? For example, when we put a substituent here at the para position, अब जैसे मैंने कहा कि that substituent can be electron donating group, or it can be electron withdrawing group. This we'll discuss in the class number 2. Or it can be any type of group. So it can be donating, electron withdrawing. For example, if it is donating, then let's say it is NH2 amine group. If it is withdrawing, let's say it's nitro group. अब nitro की वजह से क्या होगा? It will obviously try to pull the electrons from the ring. Now वो जो electronic effect है, it can be, कैसे pull करता है? Maybe it is because of the resonance, maybe it is because of the inductive effect, maybe it is due to the mesomerism, it is due to the electromagnetic effects. Now ये जो सारे effects है जिनकी वजह से the nitro group can actually create the disturbance in the electronic distribution in the ring. So it all includes these electronic effects. So the measure of all those electronic effects that gives us by the sigma x, and the mechanism of the reaction or the transition state, इसको understand करने के लिए this is being taken care by the rho x. Now this is your Hammett equation. Now I will try to put up the definition. Now let's try to have the definition of this Hammett equation, what it says. So in general, इस equation को mind में रखते हुए Hammett equation what it does. So I will write down the definition. I will write down the definition. So this equation relates a reaction या rate of reaction or reaction rate, यानी किसी भी reaction का rate or rate of any reaction, it relates this and equilibrium constant, यानी इन दो टर्म्स को reaction rate and equilibrium constant with, it relates them with it relates the rate of reaction and equilibrium constant of ortho and meta substituted compounds. It relates the reaction rate, equilibrium constant of ortho and meta substituted compounds with, it relates them with two parameters, Number one parameter, it relates them with electronic effects. So it relates them with the electronic effects, that is your sigma, and it relates them with the reaction constant. Or it relates them with the mechanism. That is your rho. So it relates the rate of the reaction or it relates the equilibrium constant in compounds which are ortho and meta substituted. Now this is very important because substituent is very important as far as the Hammett equation is concerned. Those substituted compounds, it relates them with the electronic effects and it relates them with the mechanism. Means in nutshell, what is the output of this whole Hammett equation? What actually it wants to tell us? It helps us. So what is the application of this Hammett equation? It helps us to know the mechanism of reaction. It helps us to know the mechanism of a chemical reaction. And it helps us to the optimization of reaction conditions. Optimization of reaction conditions. क्या मतलब mechanism of chemical reaction जो मैंने पहले भी डिस्कस किया. You try to react the two reactants and you want to get a particular product, you want to synthesize a particular compound. To know the mechanism, it's always important that we should know the mechanism कि कैसे ये reaction हो जाती है, कैसे ये product बन जाता है. Number one. Number two, optimization. देखिए, it's not always easy that we'll react A plus B and then we'll get the product within 1 hour or within 10 minutes or within 2 hours. Sometimes it takes 24 hours, sometimes it's 3 days, sometimes 10 days, sometimes 20 days. ऑब्वियसली अगर टाइम ज्यादा लगता है, अगर कंडीशन बहुत हारिश है, इफ वी नीड हाई टेम्परेचर, इफ वी नीड हाई प्रेशर, इट्स ऑलवेज डिफिकल्ट टू सिंथेसाइज दिस कंपाउंड. यू नीड अ सोफिस्टिकेटेड लैब. सो ऑलवेज एक चैलेंज होता है रिसर्च में दैट कि हम वी शुड सिंथेसाइज अ पर्टिकुलर कंपाउंड, बट जो कंडीशंस है दे शुड बी नॉर्मल कंडीशन. फॉर एग्जांपल we can synthesize the compound within 10 hours or 4 hours or 1 hour, जल्दी जल्दी जितना हो सके. नंबर 2, हमें कोई टफ कंडीशन ना देनी पड़े which is very difficult or which is not possible in normal labs, and we should make a simple maybe 50-degree heat or 100-degree heat up something, make it very simple. So उसको कहते हैं optimization of the reaction condition. ऐसी conditions डिजाइन करना so that the reaction goes easily. We'll get maximum yield. More number of reactants react to form the products. So the yield should increase. The condition of the reaction should be easy. So all this comes under the optimization condition. So knowing the mechanism. So Hammett equation helps us to know the mechanism, number 1. And also it helps us to optimize the reaction conditions. So this is all about the basics of the Hammett equation. Now, what is the limitation? Just one limitation I will point out here in today's class. That limitation is, so what is that limitation? That also want to discuss. Limitation ये है, if you come to this reaction again. So what I mentioned that effect of substituents at the meta and para position on dissociation of this particular carboxylic acid, or if there's any type of reaction, what is the effect of these the substituent at the meta and para position on that particular chemical reaction. इसमें एक important चीज ये भी तो है कि अगर यहाँ पे हमारे पास substituents है, इनके बीच में steric hindrance हो सकती है, क्योंकि we know the steric effect is one of the important effects in the organic chemistry. It creates a lot of things. It changes the the scenario of the products. Sometimes it changes whether the reaction will happen or not. That is also decided by the steric effects. So steric effect is very important in the organic chemistry. But if you talk about the Hammett equation, it doesn't takes into the consideration the steric effect. The limitation ये है that Hammett equation, it doesn't takes into account the steric effect of substituents. Steric effect of substituents. इसमें और भी चीजें हैं, जैसे मैंने पहले भी कहा, these are the basic crux to understand this. Have some understanding. So again, I will go back to today's class. So we started with the Hammett equation. This is one of the important equations in the organic chemistry. What actually it is log of Kx by Kh, that is equivalent to rho x multiplied by sigma x. अब ये terms क्या है? For that we'll take the same example of benzoic acid as was taken by the Hammett. ठीक है? So that benzoic acid is a weak acid. It dissociates to give benzoate ion and H plus, and this is your conjugate base. ठीक है? Now, if we have substituents at this, if we don't have the substituents inside the ring, then the rate of reaction is given by Kh. If we have substituents at the meta and para position, then the rate of reaction is given by Kx. Fine. And then we have this sigma x. It's a measure of the electronic effects. Which type of effect, resonance, whatever. And rho x, it tells you about the mechanism of the reaction, or it tells you about the transition state. ठीक है? So this is all about your, in general, Hammett equation. And then if you want to know about the definition, it's a equation that relates the reaction rate and equilibrium constant of ortho and meta substituted compounds with two parameters. Number 1 with sigma, and it relates them with the rho. So what is the application? With the help of Hammett equation, it helps us to know the mechanism of chemical reaction, number 1. Number 2, it helps us to know the optimization conditions. In optimization, how can we optimize a chemical reaction? A limitation, it doesn't take into account the steric effect of the substituents. Now, ये तो आज का था basics about this relation, this mathematical relation. ना इसके अलावा मैं जो इसके जो main points है, we'll try to understand this transition state. We'll try to understand the reaction coordinate, the diagram. Then we'll also this term kx, sig kh, electron donating, electron withdrawing effects. So that we'll discuss in the detail hopefully in the next class. Maybe tomorrow or maybe this, but hopefully within this week or within 2-3 days I will try to cover up. Hope you understood this portion of the today's class. If still you have the questions or any confusion, so please write down the comments, or you can you're always there to write the message. So thank you.